Hi, I'm Jade Suter. Hi, I'm Megan Judge. Hi, I'm Jordan Brewer.
The purpose of our lab was to use a CO2 sensor to measure the carbon dioxide gas in the crickets. This showed that the crickets carried out cellular respiration. Cellular respiration is the process of metabolism where sugars are broken down. The steps of cellular respiration include glycolysis, the Krebs cycle, and oxidation phosphorylation. This was stated in the biology textbook by Campbell 2017. For our lab's hypothesis, it was if more crickets are present in the chamber, then the initial rate of carbon dioxide gas will be faster. The main materials that we used for this lab were 15 healthy crickets, a balance, a CO2 sensor, and the biochamber 250. For this lab, after we gathered our materials and put on gloves and goggles, we masked the chamber before and after by adding 5 crickets, then recording the mass. We used the lab Quest sensor and started recording, and after 50 seconds, we stopped and recorded the initial and final mass of CO2 gas. Then, we repeated steps 2 through 4 for 5, 10, and 15 crickets with 2 trials of each. Then we cleaned up the materials and calculated the cell respiration rate.
Here is our graph and data tables. Our graph is titled The Average Rate of Respiration Based on Cricket Quantity. In the bottom here, you see that we have the quantity of crickets, which is our independent variable. We used 5, 10, and 15 crickets. On the side here, we have the average rate of respiration, which is ppm per seconds per gram, and we did it in a 50-second trial. And then the data table shows this is trial 1, this is trial 2, and then the averages. And then we have the number of crickets, the mass of each trial, and then the initial CO2, the final CO2, and the change in CO2, which is found by taking the final minus the initial CO2, which is indicated here. And then we have the rate of respiration, which is the CO2 gas over time over mass. And then we took the averages of all of these trials. So we also found the standard deviation, which is indicated right here. And then we used the standard deviation to find the standard error bars. And we used 2 of them, and we graphed them right here. And since the bars overlap, we found that the results are by chance and that there's no significant difference in the number of crickets down here.
The purpose of this lab was to use a CO2 sensor to measure the concentrations of carbon dioxide gas produced by crickets. Our hypothesis stated that if more crickets were present in the chamber, then the initial rate of carbon dioxide gas will be faster. Our hypothesis was proven incorrect. Based on the graph that Megan has just described, she mentioned that the error bars do overlap. We found that using standard deviation and the 2 standard error bar equation. And since they overlap, it indicates that there's no correlation between the amount of crickets and the amount of CO2 gas. Sources of this lab include the crickets used. So throughout the day, they had been used throughout the day, meaning that their lung capacity might have been lower just because they had been moved around a lot, and getting them in the little containers, they were put under a lot of distress. And also, using the same crickets over and over again can make their lung capacity go down or make them start to breathe less. So that could be a source of error. Also miscalculations, and also analyzing the graph. You had to pinpoint the exact part where the slope started and when the slope ended, which was the 50-second period. But also, it might have been either more accurate or less accurate depending on where you started the graph at. The limitations of this lab include the lack of amount of crickets that we had. So if we had had more, we could have used new crickets during each trial, but due to the limitation of the amount, we had to reuse some crickets. So we just kind of gave them a break in between, but that could also have caused a source of error and its limitation. And then improvements for the lab would include giving the crickets more time to rest in between each trial. Also, we could have conducted more trials to get more accurate data, as well as being more careful handling the crickets and being more accurate when we're putting the sensor into the chamber so that we start it at the right time and stop it at the right time. Overall, the lab was successful, even though the hypothesis was proven to be false. It was still a successful lab because we got to learn that crickets do undergo cellular respiration.
Thank you for listening to our Cricket Lab video.